Hello friends, this video on Biomolecules Part 9 is brought to you by examfear.com. No more fear from exam. Having talked a lot about glucose, let's start with the fructose. The names fructose came from this fruit, F-R-U, this came from this fruit. Also called fruit sugar. It was discovered by a French chemist, Pierre, in 1847. Right? From fruit actually, and the pure dry fructose is very sweet. It's very sweet. So if you see, they have the molecular formula of C6H12O6, right? And on the basis of the reaction, again it was found that it has ketonic functional group. So if you see, glucose and fructose, they have same formula, but glucose was aldehydic and this has ketonic functional group. Correct. And as I told, it belongs to D series. It belongs to D series, and also it is levo-rotatory compound. The glucose was dextro-rotatory compound, so we used to use D plus. Here it is D minus. This is the structure of fructose actually. 1, 2, 3, 4, 5, 6 carbon. It has a ketone group. Glucose had aldehyde group. Please remember, glucose has aldehyde group and my fructose has ketone group, and this is D minus. This is also D because OH group is on the right hand side. This is the three-dimensional structure of fructose. And this pure and dry fructose is very sweet, white. This is pure white. It's odorless crystalline solid. This is most water soluble sugar, and this is generally found in honey, grapes, root vegetables, flowers, etc. And commercially, this fructose is derived from sugarcane, sugar beet, etc. We see the reaction sugarcane on hydrolysis give equal amount of glucose and fructose. So this is about fructose. We have this molecular formula similar to glucose. The only difference is the fructose is ketonic group, the glucose is aldehydic group. The fructose is levo-rotatory, that is D minus. The glucose is dextro-rotatory, it is D plus. And the name of the fructose came from fruits, also called fruit sugar. Let's see the preparation of fructose. Same reaction we have seen. We have this sucrose. We use the enzyme called sucrase, the enzyme. This enzyme helps us in breaking this sucrose into glucose and fructose. And fructose has a different structure. If you see, it has a pyrene structure, this has a furan structure. We will talk about the structure of fructose. This is same reaction which we have seen. See, this is sucrose on hydrolysis in the presence of catalyst and some acid. You get fructose and glucose. And this is my sucrose, that is my sugar cane. So let's talk about the structure fructose in a little bit more. So this is the open structure of fructose. Similar to glucose, glucose also has open structure and cyclic structure. So fructose also has two cyclic structures. Correct? These two are the cyclic structure of fructose. Here also, if you see, what happens is the reaction happens between this OH and this carbon. Now if you see here, in this chain you have only 1, 2, 3, 4 carbon and 1 oxygen. Correct? If you see, in the chain we have only 1, 2, 3, 4 carbon and 1 oxygen. So you get a structure similar to furan. So it is also called furanose structure. Correct? So we will draw a Haworth structure of fructose now. So let me draw the Haworth structure of this. It will be something like this. This will be the Haworth structure. If you see the structure, this is linked actually. Yeah. The structure is similar to Furane. So it's also called furanose. Correct. So they are again two different forms similar to glucose, alpha and beta fructose, also called fructofuranose. Why? Because its shape is similar to furane. Correct. So we'll see the Haworth structure. Same method we want if you want to convert from Fisherman. This is my Fisherman structure. This is my Haworth structure. Right. Similar reaction we'll see here. So here also whatever is on the right will come down, and whatever is on the left will come. So let's draw from this to this. So first draw this. Let's give the number to carbon 1, 2, 3, 4. Right. So here in my case, or sorry, it will be other way around, it will be 2 because this is my first carbon. Let's number it 2, 3, 4, 5. This is carbon 2. I have CH2OH and OH2 attached. So OH is on the right hand side. I'll put it on the bottom, and this I'll put on the up. Similarly, in the carbon 3, I have H and OH. H on the right hand side, H goes down, OH goes up. Similarly, on the carbon 4, I have OH and H. OH in the right, OH goes down, H goes up. On the carbon 5, I have H and CH2OH. H goes down, CH2OH goes up. Please note, the CH2OH is always on the up. this CH2OH. Right? That's how you convert from Fisherman structure to Haworth structure. Let's see if my fructose is reducing or not. Again, same formula. I have to see if it has aldehyde, ketone or hemiacetal. So let's see. See, the best way is, I know there is a O here, so that means I have to pick either this carbon or this carbon. Only these two carbons can be reducing because I am looking for OR. Correct. Even instead of H, if you have R, it will be fine. Now, if you see this carbon, I have OR. I don't have OH anywhere. I have 2, because this will also become an R, right? Because this is not OH. This is CH2OH. CH2OH. This will also become R. So if you take C5, I have OR here. This one. I have some R here. I have an H here. And then again I have some R here. This is not hemiacetal. This carbon is not reducing. Let's talk about C2. So C2, if you take, there is a R here, that is CH2OH, some R. There is a OH here. There is a OR here. And there is a R here. Correct? So if you see, this is my hemiacetal form. Since this is a hemiacetal form, I can see that my fructose is a reducing sugar. Also, we know that all the monosaccharides are reducing sugar. We have discussed this. Correct? Similarly, here also if you see this one, if you take this carbon, C2 carbon, so I have OH here, this CH2OH I'll consider as R, this whole chain will be some R dash, and this will be some OR. See, this is also hemiacetal form. This is also reducing carbon. If you take C5, here also you will see there is OR, there is R and H. There is no OH group in this. This C5 carbon is also not reducing carbon. Only this carbon is reducing carbon. Correct? So even if there is one carbon which is reducing carbon, the whole molecule will be a reducing molecule. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.